2009 Grade 10 Galois Math Contest. Alex counts the number of students in her class with each hair color and summarizes the results in the following table. What percentage of students in the class have blonde hair? Well, that would basically be the number of students that have blonde hair divided by the total number of students, which is 8 plus 7 plus 3 plus 2. And that is 8 over 20. And as a percentage, that's 4 over 10. Well, that would be 40%. Part B, what percentage of the students in the class have red or black hair? So red or black. Well, red is 3 and black is 2. So that would be the numerator in this case. And the total is the same as before, which is 20. 20 students in total. So that is 5 over 20. And 5 over 20 as a percentage is 25%. Part C, how many students in the class with blonde hair would have to dye their hair black for the percentage of students in the class with black hair to be 20? Well, there are 20 students in the class, and we want the percentage to be 20%. So that means we want 20% of this 20. 20% of 20 is 4. Okay? So we want 4 students, basically, to have black hair. All right. Currently, there's only 2 students that have black hair. So we want to go from 2 students to 4 students. So that would mean that an additional 2 students would have to dye their hair black. And they're telling you that it's going to be the blonde hair students. So of those 8 blonde hair students, 2 would have to dye their hair black. And when that happens, there will be a total of 4 students with black hair, and that represents 20% of the 20 students. So hopefully all that makes sense. And the answer to this question is 2. Part D, how many students with red hair would have to join the class so that the percentage of students in the class with red hair is equal to 32%? Okay, so a little bit different this time. So let's talk about this, Part D. So 20 is how many we have, and we want some students to join, and I'll represent that by R. R representing the number of red hair students that join the class. And they're saying that they want this to be 32%, so 0.32, of what? Of the total number of students with red hair, according to the question. Well, we started off with 3 students, and then remember we added R. So this is basically the mathematical equation for this question. And this is just what we have to solve. So if you can get this far, the rest should be pretty straightforward. Expanding this is 6.4 plus 0.32R is equal to 3 plus R. A little bit of algebra, and you get 0.68R, and this is 3.4. And then when you divide through, you get R equal to 5. So 5 is the answer to Part D. A square has vertices with coordinates A69, B12, C T0, and D33. Determine the value of T, the x-coordinate of vertex C. Let's draw a little diagram. It doesn't have to be a work of art, just to kind of get an understanding of this. So 3, 3 approximately here, right? 3, 3, and that I believe is D. And then C is right on the x-axis, right? This is the x-axis, this is the y-axis. So that's T0, so I'm not sure what T is, but we'll just call it T. So that is C. And then 6, 9, 6, 9, let's just say that this is 6, and then 9 would be somewhere here. So that one is A, and then finally 12, 6, so 12, 6 approximately here, and that would be A. That would be B. Okay, so this is my square in a very crude way. Okay, it kind of looks like a square. All right, so we have to now determine the coordinates of C. So how would we do that? Well, as you guys know, square, all the sides are the same length, right? So if all the sides are the same length, then we can use that. First, what I'll do is I'll figure out the length of one side that I have. So A is 6,9 and B is 12,6. So I can use those 2 points to figure out the length of this side right here. So just use the standard distance formula, 12 minus 6 all squared plus 6 minus 9 all squared, and then taking the square root, right? Standard distance formula, nothing fancy here. So this is going to be 36 plus 9, and that looks to me like root 45. So root 45 is the length of one side, and therefore the length of the other side has also got to be root 45. But this time we're using C, this point right here, which has the coordinates t0. So I'm going to use, it doesn't really matter what you use, but any of these, might as well just use this guy here since we have it. This is 3, 3. So from here to here, that's going to be 3 minus t all squared, and then 3 minus 0 all squared under the square root sign. And that's got to equal that root 45 because that is the length of each side of the square. So this is 3 minus t all squared plus 9 all squared. Now we can get rid of the square root signs, just square both sides, and that gives me 45. 3 minus t all squared plus 9. Bring the 9 over, so that's 36. 3 minus t. Take the square root of both sides, and you get plus or minus 6 is 3 minus t, and therefore t looks like if we use the minus 6, it would be t was 9. And that makes sense because if you look at this diagram, it makes sense that t is 9 because the other answer would be t is minus 3, and that would bring it out here. And that obviously does not make sense according to the diagram. So you can just explain that, and that should be sufficient for part A. All right, part B. A line is drawn through 0, 0, and D, and the line meets AB at E. Determine the coordinates of E. All right, so this time we've got a line. So let me just draw that line first. And so they're saying, where does it start? At the origin, and it goes through D, and then I guess it crosses like that. Okay, so that's pretty easy to figure out where E would be. That's going to be, E is going to be right there. Okay, and what do they want the coordinates of E? Okay. So I think this is going to be one of those questions where intersection of two lines. So I have to figure out the equation of two lines. The first line is the one that I drew in red. And the second line, I guess, is the line that kind of goes right there between A and B. So let's do that. First, let's figure out the equations of these lines, and then we can find out the intersection point, and that intersection point will be E. So standard formula, y is equal to mx plus b. Let's do the line, this one, the black line right here, this guy. Okay, so the points I'm going to use are 6, 9, obviously, and 12, 6. So the slope, rise over run, you guys know about that. So 9 minus 6, 6 minus 12, and that I believe is what, 3 over negative 6, so that's negative a half. So that means y is equal to minus 1/2 x plus b. Substitute any of these points to figure out b. I'll substitute the 12, 6. So that means when y is 6, the x will be 12. So that means that b would be 12 in this case. So the first equation is y is equal to negative 1/2 x plus 12. And that is the equation for the black line. And then now for the red line, let's see if I can just squeeze it in here. I've got 2 points. I've got this one, which is the origin, and then I've got this one, which is 3, 3. So I'll use those 2 points. Same story. Y is equal to mx plus b. And let's see here. M in this case is rise over run, which is 3 minus 0 over 3 minus 0, which is just 1. And then to figure out b, I guess 0, 0 plus b, b is 0. So that means this is just y is equal to x, that line that's in red. So now I just have to figure out the intersection point of those two lines, and that will give me the coordinate for E. Okay, shouldn't be hard. So x is equal to minus 1/2 x plus 12 if you combine these two guys. and therefore 12 would be 3 over 2x, and therefore x would be, I believe, 8. And then y would be 8, since y is equal to x, and therefore the coordinate E would have 8, 8 as the answer. Moving right along, part C of this question, determine the perimeter of the quadrilateral EBCD. Okay, so perimeter. EBCD. So E to B, B to C, C to D, and DT. So the perimeter of that. Okay. I think 2 of these I know already. This side here is root 45 because it's the side of the square, and that side there is also root 45. Okay, so those 2 I know already. Now I just have to figure out the distance from E to B and the distance from D to E. Okay, so perimeter, we got those 2 root 45s in there, and then I just have to figure out the distance from D to E and the distance from E to B. And that, I think, shouldn't be too much of a problem. I'll just do them separately first. D to E, using the distance formula, is going to be 12 minus 8 squared plus 6 minus 8 squared. And this is what, 16 plus 4? So that's root 20. And then EB, using the distance formula with those coordinates that you can go back and check, is going to be 8 minus 3 squared plus 8 minus 3 squared, all under the square root sign. And that's going to be 25 plus 25, which is root 50. So that means P is equal to 2 root 45 plus root 20 plus root 50. And then let's see if we can combine this. Root 45 is what? 9 times 5, so that's 3 root 5. So that's going to be times 3 root 5, like that. Yeah, and then this one, 4 times 5, so 2 root 5. And this one, 2 times 25, so 5 root 2. So 6 plus 2, 8 root 5 plus 5 root 2. And that is the perimeter of that shape. Number 3, find the area of an equilateral triangle with side length 2. Well, there are several ways of doing this, but if you guys remember a formula, it just makes it faster. The formula is the area of an equilateral triangle is root 3 over 4 times a squared, where a is the length of the side. Equilateral meaning all 3 sides are the same. Well, in this case, they told me my a is equal to 2. So all I have to do is just plug in that into this formula, and that's just going to reduce to root 3. So that's a simple way of doing it if you remember this relatively easy to remember formula. Determine the area of the regular hexagon with side length 2. So here's the regular hexagon. Now again, there's a hard way and there's an easy way. Because I've done so many of these kinds of problems, I immediately recognize that this can be split up into basically equilateral triangles. And the fact that they gave you that in part A should give you a clue for part B. You know, they usually do that in questions where one part sort of leads into the other, that kind of thing. And that's nice of them to do that. So there you go. I just split up that hexagon into 6 equilateral triangles. And each of these has a side length 2. Correct? And yeah, that's pretty much it. Now, some of you might be a little unconvinced that these are equilateral triangles. You might say, well, how do you know that they're equilateral? Well, one thing you can do is figure out the internal angle. The internal angle of a hexagon. A hexagon, I'll just draw one here. You can split it up into 4 triangles, right? And the internal angles of each triangle is 180 degrees. So since there's 4 of them, all the internal angles would add up to 4 times 180. Now, how many internal angles do we have? We have 1, 2, 3, 4, 5, 6. So each internal angle you would get by dividing the total by 6. And that would give you 120. So each of these internal angles is 120. Now when I draw these red lines, I'm splitting that internal angle into half. So this one would be 60, and this one would be 60. You got it? This is 60, this is 60. And then because this angle is 180 minus the other two, that one's 60. So since all the angles of each triangle are 60, it's equilateral. So that's another way you can prove it. Okay, so what were we trying to do here? Determine the area. Okay, well, it's 6 of those equilateral triangles, and each has an area of root 3 according to part A. So therefore, in a very quick way, you can get the answer 6 root 3. And I would encourage you to maybe write a few sentences to explain what I just talked about. Probably is a good idea to do that. Part C. In the diagram, the irregular hexagon ABCDEF has side length 2. Using A, C, and E as centers, portions of the circle with radius 1 are drawn outside the hexagon. Using B, D, and F as centers, portions of the circles with radius 1 are drawn inside the hexagon. These 6 circular arcs joined together to form a curve. Determine the area of the shaded region enclosed by this curve. Okay, so it's a pretty interesting question. So let's tackle this here. Okay, so the shaded area, I'm going to break it up into 2 sections. The first section I'm just going to concentrate on is the one that's inside that hexagon. So that, I'll just call it inside. It looks to me like the area of the hexagon minus those 3 semicircles. So I hope that makes sense, right? Because you're basically calculating the area of the entire hexagon, and then you're going to subtract from it these 3. Well, they're not semicircles. Pi segments, I guess, if you want to call them pi segments. Well, segments, let's just call it segments, whatever, right? Okay, so that's pretty straightforward. And then I'll calculate the outside guys. And the outside guys are a little bit different, right? There's 3 of these, 1, 2, and 3, identical, whatever you want to call them, segments again. I just don't want to call them semicircles because they're technically not, right? Okay, so let's concentrate on the first one, inside. The area of the hexagon, I believe we just did in the previous question, if I'm not mistaken, right? That was a 6 root 3, I believe. Yeah. And then 3 times these segments. Now, these segments are obviously portions of a circle. And also, if I recall, I told you that angle was 120. We calculated that. So how do you figure this out is it's 120 degrees of the 360 degrees of a circle, and then the area of the circle, which in this case is pi r squared, and the radius is 1. So that's how you'd figure out those segments. So let's just do this. This is 6 root 3, and I think this is just pi. Yeah. Okay, so that's pretty straightforward. That takes care of the inside. Now the outside, it's going to be similar in some ways. Now we have to figure out this angle. Well, the internal angle is 120, so the external angle is 240. So now we've got 3 of these guys, and each segment is going to be 240 of the 360 degrees of pi r squared, where r is 1. Radius is 1. And therefore this looks like, I believe, 3 times 2 over 3 times pi, which is just 2 pi. So the total inside and outside is this guy plus this guy. So that's going to be 6 root 3 minus pi plus 2 pi, and that is 6 root 3 plus pi. So that is the answer to this question with regard to the shaded region. If m is a positive integer, The symbol m exclamation mark is used to represent the product of the integers from 1 to m. That is, m factorial is m times m minus 1 times m minus 2 all the way to 1. For example, 5 factorial is 5 times 4 times 3 times 2 times 1, or 120. Some positive integers, n, can be written in the form n is equal to a times 1 factorial plus b times 2 factorial plus c times 3 factorial plus d times 4 factorial plus e times 5 factorial. In addition, each of the following conditions is satisfied. A, b, c, and d and e are integers. A is between 1 and 0 inclusive, b between 2 and 0 inclusive, c between 3 and 0 inclusive, d between 4 and 0 inclusive, and e between 5 and 0 inclusive. Determine the largest positive integer n that can be written in this form. Okay, so throughout this question, we're going to concentrate on that. And they're saying, what's the largest? Well, the largest positive number that can be written in that form, n they're calling it, capital N, is obviously going to utilize the largest possible values for a, b, c, d, and e. So the largest value for a, I believe, is 1. So let's put that in there. The largest value for b is 2. The largest value for c is 3. The largest value for d is 4. And then the largest value for e is 5. And hopefully that should do it. So let's see. This is going to be 1. 2 factorial is what? 2 times 1, which is 2. So multiply that by 2 and we get 4. 3 factorial is 3 times 2, which is 6. 6 times 3 is 18. 4 factorial is 24 times 4 is 96. And 5 factorial, which I think they actually gave you, is 120. And therefore that times 5 would be 600. And if you add all these up, I believe this is going to be 719. So that is the largest possible. Part B, write n is equal to 653 in this form. All right. So 653. Okay. So I think this one, instead of the 1 factorial, I'm just going to write 1. Instead of the 2 factorial, I'm just going to write 2, which is what it's equal to. C, 3 factorial is 6. D, 4 factorial is 24. And E, 5 factorial is 120. So that's basically the equivalent. Now I've got to make it equal 653. And I think this is just trial and error. There's no actual, fancy way or specific formula. You just kind of go through with this. What I did was I said, okay, what could E be? Keeping in mind that it's got to be between 0 and 5. And I thought, well, could it be 5? If it's 5, then that would be 600. And I thought, yeah, that's pretty decent. Okay, so let's try 5. Let's see what happens. So let's keep a tally here. If E is 5, then that means I've got, this is going to be, what, 600, right? Yeah. So that means of the 653, I still got 53 left that I've got to somehow create. Okay. So then D, how many times does 24 go into 53? It goes in two times. So I think I can make that a 2, which is 48. Okay, so I still got 53 minus 48, which is 5 left, correct? Okay, 5 left. Whoa, that's 6. So I think that C is going to be a 0 because I've made D a 2. So I don't think I can make, and if C was 1, it would be 6, and I only have 5 left. Okay, can I make a B? Yeah, I could probably make at least 2 B's. So B would be 2. And then once I do that, I had 5. This is equal to 4. So now I have just 1 left that I have to account for. And therefore that can make that a 1. And that's it. I think this works out. Yeah, 653. So that's all it is. It's just basically you're just fiddling around with the numbers to see what you can do to make up 653. So A is 1, B is 2, C is 0, D is 2, and E is 5. And as you can see, they all comply with the parameters that are given. Okay, now we're getting into the harder stuff. Prove that all integers between 0 and large N inclusive can be written in this form. All right. Well, we're going to need a lot of space for this. So first of all, we are given a certain parameter, right? They want to be between the large n, which I believe was 719, and 0. Okay, so that's my parameter. And then let's remind ourselves what was a. If you remember, a was 1 times a plus 2 times b plus 6 times c plus 24 times d plus 120 times e, right? I just expanded it all out. Now what I'm going to do is I'm going to break these up into segments. And I'm going to actually start with the largest one. And I'm going to call this whole segment x1. And you kind of will see why. Now with this, we've got to write our parameters so that we abide by the rules sort of of this question. Now, if this is x1 right here, representing all these guys, it must be less than 120. And that's very important. So I'm going to actually put a little star here to indicate its importance. And the reason is because if it was greater than 120, then we would be able to include it in that part of the equation. You see what I mean? If it was, for example, 121, then this would basically be able to cover that. And we would just put e plus 1. So this is a very important equality that must be maintained. Okay, so far nothing fancy. Don't get confused. I just want to break this up. Now I will continue to break it up with x1 by bringing into this the 24d. Now this time I'm splitting these three guys into x2. And x2, in a very similar way, in terms of the logic of this question, must be less than 24. Because if it was greater than 24, it could be included into that term, right? It would be d plus 1 or whatever, d plus 2. Okay, keep going. And then I think you can kind of see where I'm going with this. The next one would be 6c plus x3, where x3 represents these two guys. And x3 has got to be less than 6. Keep going. 120e plus 24d plus 6c plus x4. No. We got to give one more term here. 2b plus x4. And I think x4 is just sort of, at this point, just representing just this guy here, the a1. So x4 is obviously got to be less than 2. And then finally, I think that's it. I think that's pretty much it, because we've exhausted it all. And I think that's about as far as we need to go with this. Hopefully that's it. I think we can do one more just to sort of finish it off. That we've got all these guys, but let me just put in the a just to be, yeah. So since it's 1a, I'll just put it in there, plus x5. And x5 obviously has to be less than 1 and greater than 0. But this means that x5 is equal to 0 because it's got to be an integer, right? That's what they told me in the question. Yeah, they're all integers. Yeah. Okay. So this was the first part of the question, just to sort of give the parameters. Now we move into the second part of the question, which kind of proves that this can be done with these parameters in mind right here, these guys. So all of these integers that are between 0 and 719 can be written with these parameters. So that's what we have to show now. Okay, so let's do that. Okay, so hopefully I can do it all on one page so you guys can see. So we got that parameter up there. Okay, so let's start. Let's start with the first one, that n was 120e plus x1. And that's got to be less than or equal to 719, which is my first one right here. Correct? Okay. Now, since we know that x1 is greater than 0, as I have listed here, that means that e times this 5 factorial, or 120e, has got to be less than or equal to 719. I'm just combining this with this fact. And therefore, e has got to be less than 6 if you were to divide both sides by 120. And that definitely satisfies my parameter that e is less than or equal to 5, less than or equal to 0. And keeping in mind that e is an integer, and you can't have like a 5.5 or something like that. So it's always going to be an integer. So all of this basically proved that this can be done with e being in that range. So that's the first part. The next part is just basically proving the same thing, but not for e this time. We have to prove it for d. So it's very similar. So we are told that now we have x1, which was greater than 0 and less than 120, right? But then we've got this next one, this next equation, that x1, which I had used to represent, I guess, this guy right here, which is 24d plus x2, is less than 120. Now, since we know that x1 is greater than or equal to 0, that means that 24d has got to be less than 120. I'm combining this with this. And therefore, if you divide through by 24, you get d is less than 5. And that satisfies the inequality that, or the parameter, whatever you want to call it, that d is between 4 and 0 inclusive. So that takes care of d. And in a very similar way, we keep on moving forward for c and b, and then finally a. So hopefully I can fit it all in here. So let's move on to c. So similarly, x2, if you remember, was greater than 0, but it's less than 24. I think that was up here. Yeah, right here. So that's why those parameters were important. And then we know that x2 was representing 6c plus x3, right? 6c plus x3 is what x2 is representing. And that's got to be less than 24. But since we know that x3 is greater than or equal to 0, that means 6c has got to be less than 24. I've combined this with this. And then if you divide through by 6, you get c is less than 4. And that satisfies the parameter that c is less than or equal to 3, but greater than 0. Got it? So that takes care of c. And then we just got b and a, and then we'd pretty much done the question. Okay, so next one is b, same kind of thing. x3 we know is going to be between 0 and 6. That's from up here. But x3 was representing 2b plus x4. And since we know that x4 is greater than or equal to 0, we can deduce that 2b is less than 6. Combining that with that, divide through by 2, and therefore b is less than 3. And that satisfies the parameter that b is less than or equal to 2, greater than 0. And then finally, by this point, you're an expert. You can do the last one, which is a. x4 is less than 2, greater than 0 from up there. And x4 was representing a plus x5. So I think this is just that shouldn't be there. It's just less than. And then since we know that x5 is actually 0, a is less than 2. And that satisfies the final parameter, which is that a is less than or equal to 1, greater than 0. So we figured it all out and proved that any number can be written in this form right here using these parameters right there. And finally, we have part D of this question. Determine the sum of all integers n that can be written in this form with c equal to 0. So here is our equation right here, the big one. And we want to set c equal to 0 and figure out all such possible n's and then add them all up. All right. Okay, so as before, n is equal to a plus 2b plus, let's see here, same as before, right? 24d plus 120e. Now you say, well, what happened to c? Well, c is 0, so that one vanished, that term. It would be c times, I believe it was 3 factorial, right? But it doesn't matter because c is 0. So all the possible n's of this form. Now, of course, we still have some parameters. We have a, which is between 1 and 0, b, which is between 2 and 0, d, which is between 4 and 0, and e, which is between 5 and 0. So as you can see, we've got a lot of choices, a lot of numbers here, but we would have to manually calculate each one, which would be very time consuming, and then add them all up. So let's see, is there a quicker way of doing this? Well, first thing I want to do is see if I can kind of simplify this a little bit. 2b, it looks like a 24 factors, and I get d plus 5e, I believe. So that's a little bit beneficial here. And what I'll do is I'll call this guy n1, and I'll call this part n2. Yeah. And then we can kind of play with this a little bit. So let's make a little table here. N1, which is a plus 2b. And then N2, which is d plus 5e. And let's just see. I'm not going to do it all, but I mean, I think we'll get somewhat of an understanding of what will happen. A is between 0 and 1. So let's see what happens when we have A and B. If A is 0, B can be 0. A is 0, B can be 1. If A is 0, B can be 2. So that we've exhausted the A equals 0, 1. The only other value for A that's possible, because it's an integer, is 1. A could be 0, 1, 1, or 1, 2. And I think that's it. So therefore the N1, if you calculate it, would be, let's see here, 0, 2, 4, 1, 3, 5. Yeah, if you plug these A and B's into this formula. Okay, so that's pretty decent. That means that I've only got 0, 1, 2, 3, 4, 5 as my possible answers for N1. Okay, but something tells me that N2 is not going to be that simple. But at least we can get somewhat of an understanding. Same thing, let's put D here, E here, and let's see what we get for N2. D is between 0 and 4, so let's see, if it's 0, E could be between 0 and 5, correct? So 0, 1, 2, 3, 4, 5. So that's for 0, 0, 0, 0, 0. And I'm just going to do one more because obviously it's going to be very time consuming. It actually would be 5 times 6, 30 different cases. So at least we know, let me just write that, 30 cases, right? Because you have 5 possible choices for D and 6 possible choices for E. So 5 times 6, that's why there's 30 cases. I'll just list, how many should I list? Another set, I guess. So let's do with D1. Yeah. So 1, 2, 3, 4, 5, 6. And then, of course, 0, 1, 2, 3, 4, 5. Okay. Now let's figure out the n's, the calculation for n using that formula. Let's see here, 0, 5, 10, 15, 20, 25, and then 1, 6, 11, 16, 21, and 26. Yeah. Okay, so N2, let me just write it over here. It looks to me, if you kept this going, and 30 cases isn't really that many, right? So you could probably do it manually. And when you do, you'll find that you'll get every single possible number from 0 all the way to 29. Dot, 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 29. Every integer from 0 to 29. And that is indeed 30 cases, so that, matches what we had predicted. Okay, great. So let's keep in mind, n is this guy. We know these are the possible values for n2, and these are the possible values for n1. All right, but we would just have to add them. And if we add them, then if you add n1 and n2, then you get n, and then we have to add up all the n's. So first, let me just illustrate how we're going to do that. So n was n1 plus 24 n2, correct? And then n1, there was only, I believe, 6 possibilities in terms of what n1 could equal. And n2, there was 30. It kind of went all the way till 29. So that's sort of the story here. Now, let's figure out, how do we possibly get n, this guy right here? Well, the first thing, of course, is to keep in mind that it's not just n2, it's 24 times n2. So 24 times n2 is really what we're adding when we try to figure out n. So 24 times n2 would be 0, 24, 48, 72, dot, 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 all the way to 24 times 29, which I believe is 696. So you're really adding this guy with this guy. So you've got how many? 6 possible choices here and 30 possible choices here. Yeah. Okay, I got it. Yeah, I got it. Okay, so let's just make a little, I'm not going to obviously write them all out, but let's just make a kind of a table. So before I start making the table, I think there's going to be 180 numbers, right? Because for the first guy, for the first term, you got 6 possible choices. For this next term, you got 30 possible choices. So 6 times 30 is 180. So let's see what happens. When I take n1 equal to 0, and then I use these numbers, I will get 0. Or actually, let me make it a little bit different. Let me start off with this guy and then go through the n1s. I think that's a little bit better. So if I have n2 fixed as 0, then n would be equal to 0 or 1 or 2 or 3 or 4 or 5. You got it? Remember, we're using that formula. Now let's go to n2 fixed as 24. So 24 times n2, which is this term right here. If that's the case, then as I go through the n1s, my values for n will be 24, 25, 26, 27, 28, 29. Yeah, that's good. And then if I move to 24 n2 as 48, that being the fixed value, and then I go through values of n1, then I'll have 48, 49, 50, 51, 52, 53, like that. So I hope you get the point. And then eventually, when I get down to final 696 as the fixed value for 24n2, and then go through the values of n1, I will get 696, 697, 698, 699, 700, and 701. So as predicted, I'm going to have 30 sets of 6. This is 6, this is 6, this is 6, and this is 6. And now my task is I have to add up all these guys. So that is the final part of this question. So here we go. All right, so this is basically showing how you can add up all these numbers in a relatively structured way without having to do it manually. It would be very time consuming. So the first row here, this one right here, is showing you all the numbers that are right here. So starts with 0, 1, 2, 3, 4, 5, and then 24 through 29, then 48 all the way to 53, and then 696 all the way to 701. So this is all the numbers. Obviously, there's a dot, dot, dot here because there's several. Then we're going to group them. So the first ones, you just leave alone. But the next one, if you notice, it's 24 plus 0, 24 plus 1, 24 plus 2, and so on. So a little bit of a commonality there that each of these are going up by ones. And similarly, 48 plus 0 plus 1 all the way. And then similarly, the last ones. And then what you do is you recognize that you can factor out the 0, 1, 2, 3, 4, 5. The first group here, let me just put in these equal signs. The first group here is the first group up here. But then every single other group has a 0, 1, 2, 3, 4, 5 in it. And that's why you have these guys here. And what you've really done is you've just taken out the 24s, these guys, and since there's 6 of them, you have to multiply by 6. And then you just add the 0, 1, 2, 3, 4, 5, and that's what this is. And then you do the exact same thing for the next set of 48, 49. You take out all the 48s, and then because there would be 6 of them, you multiply by 6, and then you add the 0, 1, 2, 3, 4, 5 that comes from each of those terms. And you just keep doing that. So you do that until the very end, which is the last ones. You take out all the 696s, and you multiply by 6 since there was 6 of them. And then you just add the 1, 2, 3, 4, 5, which is what they've done here. Okay, so now we got to combine all of these. As you can see, there's a 1 through 5, a 1 through 5, a 1 through 5, and 1 through 5 for each set. And remember, there was 30 sets, so that's why there's a 30 of them. And then you can just kind of list all the other remaining 24 times 6, which is from here, 48 times 6, which is from here, dot, 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 all the way to the 696 times 6, which is from there. And then this 0 plus 1 plus 2 plus 3 plus 4 plus 5 is 15. So that's why that becomes 15. And then these guys, you factor out the 24 times 6. And then if you do that, this would be 1. This would give you a 2. The next one would give you a 3. And then this one would give you a 29. And then this can be added with that formula you guys remember. N times n plus 1 over 2 for consecutive integers. So that's what they've done there. 29 times 30 over 2. And then finally you got just that, which is easily crunchable into one final number, which is 63,090. So pretty challenging question, and that's how you do it.